Measurement and significant figures are a very important topic for science and this course as well. So it's really important to know how to record measurements properly. So you've been measuring stuff since you were very young, but in science it's really important to measure with the proper number of decimal places. So for instruments with a scale, you get the last digit by estimating between the marks if possible. So we can mentally divide that last space into 10 equal spaces and estimate where the mark lands. So we want to record everything we know for certain. So in this case, for our pink mark on our ruler, we know that it is 7 centimeters for sure because it is marked on our ruler. We can look at the hash marks and see that we are at the 9th hash mark that is marked, so we know that for certain. Now we are going to estimate the last spot. So we know that it falls between the 9 and the 0 for 8 centimeters. So we look at that and we see, well, it looks like it's a little bit less than half. So I would estimate that it is 7.93 centimeters. Now, if you estimated slightly differently in this last digit, that's okay. That's why this is our uncertain digit. If you estimated it at 7.94 or 7.92, that is completely understandable because we're doing that estimate at that last mark. Now, depending on the scale that we're using, that gives us different decimal places that we can measure our object to. So in this case, we're measuring a pistachio because we really want to know what the mass of a pistachio is. On the first scale, because we have markings for every gram, so 0 grams is marked and 10 grams is marked. That means each line in between is 1 gram. We can estimate between the marks so we can get 1 decimal point in our reading. If we look at the other scale, now every gram is marked and the lines between them are tenths of a gram. So every 0.1 grams is marked. So now when we make our reading, our estimation happens at the 100th place or the second decimal place. And so we can make this reading even more accurately, and we're required to write down that second decimal place. So take a look at this graduated cylinder. What volume of liquid do you think, if we measure it to the proper number of decimal places, what is the volume in our graduated cylinder? Pause the video if you'd like some extra time to think about your answer. Well, we have the ones place marked. That means each line in between is a tenth. And so we know for certain the 4, we're reading up. We always read from the bottom of the meniscus. So the meniscus is that dip in the liquid. We know for certain that we have 4 milliliters. We can see that we're between the 5 and the 6 mark. So we would have 4.51. We would need that 100th place to be a proper measurement. How do we count significant figures? Well, we have a list of rules that we can follow. So any non-zero digits are significant when we're making a measurement. So again, we're thinking about making measurements here. So any non-zero digit that you record is significant. If the 0 is on the inside of the number, it is significant. So in this case, 1.05, every one of those digits would be significant. Leading zeros, so zeros on the left-hand side, are not significant. They are placeholders for us. They hold the place of where our decimal belongs. Those are not significant. So in this case, the 1, the 0, the 5, and the 0 would be the significant digits, giving us 4 significant figures. The reason for this is if we write it in scientific notation, those zeros disappear, which might be an easier way for you to count your significant figures. We would have to move that decimal point 3 places to the right. That's why we end up with a -3. Trailing zeros may or may not be significant. It depends on our decimal point. So if the decimal point is present, the 0 is significant. So in this case, 1.050 would have 4 significant figures. Again, for part B, 150.0, we have a decimal point that's present. And so that last 0 is significant, giving us 4 significant figures. Now, if we do not have a decimal point present, it becomes ambiguous. It's hard for us to tell how many there are. So we may have to write it in scientific notation in order to tell us how many decimal places we correctly have. So if we want to represent 150 with 2 significant figures, we would write it as 1.50 times 10 to the second, because in this case, we have to move the decimal place to the right 2 places, which gives us a positive exponent. If we wanted to show that it had 3 significant figures, then we would write 1.50 times 10 to the second. Now, once in a while, you'll see it written like this with no 0 after it. And the reason for that is they're trying to show that there are 3 significant figures, which we abbreviate sig figs. If we have an exact value, so a counting number or a definition like in our metric system, so 1 centimeter is exactly equal to 0.10 with as many zeros as we want to put behind it. That means that they have unlimited number of significant figures. Or if it's an integer value, because it's an exact number as well with unlimited numbers of zeros behind it. Those are exact numbers, again, with unlimited numbers of significant figures. So here's an example for you. We're going to try to determine how many significant figures are in the following. So pause your video and estimate, or not estimate, count the number of significant figures. Okay, so for the first one, we've got leading zeros, so those are not significant, but we have a trailing 0 that is. So in this case, we have 4 significant figures, or sig figs for short. In our second example, we've got interior zeros, and those are significant. So in this case, we have 5 significant figures. 10 decimeters equals 1 meter. Well, this is infinite or unlimited numbers because it is a definition. So there's exactly 10 decimeters in 1 meter. Our next example, now we have scientific notation. So we're looking at just the beginning part. We have a decimal place present, so that makes all of those trailing zeros significant. So in this case, we have 4 significant figures. All right, second to last example, how many significant figures do we have there? Well, in this case, we just have 1 significant figure. Why is that? Well, that's because we have leading zeros, and we could write this as 2 times 10 to the negative 5th. So none of those zeros are significant. How about our last one? 10,000 meters. Well, this is ambiguous. It's hard for us to tell how many significant figures there are, but we would assume that there is 1 significant figure because we don't have any other information to tell us otherwise. We could write this as 1 times 10 to the 4th meters. Now, when we make measurements, we usually do some sort of manipulation with those measurements. So if we're undergoing mathematical operations, we need to know the proper way to handle our significant figures. If we are multiplying or dividing significant figures, then the least number of significant figures in our multiplication is the number of significant figures we can have in our answer. So because we have 2 significant figures here, we can only report our answer to 2 significant figures. For our division, same rule applies. Whatever number has the smallest number of significant figures, that is the number of significant figures that we can report in our answer. So I generally just call this least number of sig figs. Addition and subtraction have a different rule. So when we're adding or subtracting measurements, it is the least number of decimal places that defines how many significant figures we can report. So here, because this measurement only has 2 decimal places, our answer can only be reported to 2 decimal places. For our subtraction, same rule applies. We only have 1 decimal place, so our answer can only be reported to 1 decimal place. It may seem silly to bring up rounding, but when we are rounding values for our significant figures, the number that we're going to drop, if it is between 0 and 4, that last significant digit stays the same, or we round down for that last significant digit. If the number we're going to drop is between 5 and 9, we round up, so that last significant digit gets rounded up. Now, in order to make sure that we're not adding extra rounding error in, we want to make sure that we don't do any rounding until after we've completed our mathematical operation. So we want to keep track of that last digit, which I usually do by putting a line but underneath the value, but we don't want to do the rounding until we're completely done with all our mathematical operations because it could change our answer. So if we're rounding to two significant digits, two significant figures, that is at the 3, because the digit we're going to drop is a 4, it stays at 230. We have 237 and we're rounding to 2 because that 7 is larger than 5. That rounds up to 240. We're rounding our last example here. Even though it's really, really close to 5, because that last digit is a 4, we round down to 230. Now, it may seem silly to talk about rounding, but depending on the chemistry class that you're in and how precise and careful they are, sometimes the rounding rules change. We're sticking with the simple rounding. Things get a little more complicated when we have both multiplication and division and addition and subtraction in the same mathematical problem. We want to follow the rules by the order of operation. So we start in, for our example here, we would start inside our parentheses. We would take and we would subtract these two numbers, giving us 3.37. Now, because we're doing subtraction, we follow the rule of decimal places. So we have one decimal place in our answer. When we do our subtraction, we're only allowed one decimal place. We put the line underneath to represent that that's our last significant value. We don't want to round yet, because if we round, it could introduce some rounding errors. So we're going to write our 7 down. We're going to use it in our mathematical multiplication here, but we know that that 3 is our last significant digit. Now, because our next step is to multiply, we're going to multiply the two values together. We're only allowed one decimal place, which is a total of two significant figures, the 3.3. And so we multiply these together. We have to follow the rule for significant figures. So here we have 4 significant figures. Here we have 2 significant figures. So our answer, we are only allowed to report 2 significant figures for an answer of 12. Okay, so pause the video, attempt these problems to see if you understand how to do significant figures and report your answer to the proper number of significant figures. For number A, or for part A, we have all multiplication and division, and so we can multiply and divide our answers and get a value . 0.65219. Now let's look at how many significant figures were allowed in our answer. So we have 3, we have 4 for this number, we have 5, and we have 5 significant figures. So the least number of significant figures is 3. That leading 0 is not significant, so we are only allowed 3 significant figures in our answer. Okay. For B, now we're doing addition and subtraction. So when we add the first two values, subtract the third value, we end up with an answer of 4.8730. Now the rule for addition and subtraction is least number of decimal places. So here we have 3 decimal places, 1 decimal place, 4 decimal places. So our least number is 1. So we would have to report 1 decimal place. Our 7 is larger than 5. So our answer would be reported as 4.9. Now we have mixed operations. We have multiplication, division, and subtraction. So where would we start for this problem? Well, we'd start inside the parentheses with our subtraction. So we would do the subtraction inside the parentheses. Okay? Because we're doing subtraction, our rule is least number of decimal places. We have 2 decimal places. So we are only allowed 2 decimal places in our answer. Okay? Now we can multiply and divide the answers that we've found. We get 52.79904. Now because we've done multiplication and division with the answer, now it is least number of significant figures. So we have 4 significant figures. We have 6 significant figures. And because we're only allowed 2 decimal places, this only has 2 significant figures. Remember, leading zero is not significant, so we are only allowed 2 significant figures in our answer. So we would report this as 53. Now, if this is difficult for you, you're not alone. This can be a challenging topic. It takes practice in order to be able to see these and to carefully figure out the number of significant figures. Let's look at D. Okay, we're going to start inside the parentheses and do our multiplication. We have 2, because we're multiplying, we have 2 significant figures. We have 4 significant figures. So we're only allowed to report 2 significant figures. Now we're going to subtract. What's the rule for subtraction? Least number of decimal places. So now we have to look at decimal places. This has 1 decimal place. We're subtracting 2 decimal places. So the least number of decimal places is 1. So we are only allowed to report 1 decimal place in our answer.